We are going to work Practice Test A, the first part, objectives 1 through 6, looking at chemical quantities, the mole. Our first objective, I'll read for us out loud. We're being asked to determine the number of representative particles in a mole of any substance, or determine the number of moles given the number of representative particles of any substance. Visually on our mole map, objective 1 entirely is based in the world of Avogadro. We are going to count and convert into the mole, or given a mole, we'll head out and count. So objective 1 literally is this road only on our mole map. We'll either be giving particles and divide by Avogadro to head in, or given the number of moles and we'll multiply to head out. Objective 1, every step, every unit, every time. So let's begin by reading. How many moles of magnesium are in 1.5 times 10 to the 23rd atoms of magnesium? The individual particles called atoms starts us down here. Imagine those as just little atoms of magnesium. And we want to exchange that into the unit mole, converting atoms to moles using Avogadro. Let's begin by writing our number, 1.5 times 10 to the 23rd. The unit is atoms, and the label is magnesium. This is a vocab match. Elements are built of atoms. This will be a one-step problem. My conversion factor has us canceling the atoms and heading into the mole. We will write that 1 mole of magnesium would contain exactly 6.02 times 10 to the 23rd atoms of magnesium. Starting with atoms, we place atoms on the bottom so that the unit will cancel and it will bring us into the mole. Visually, atoms into the mole, we can see that Avogadro is placed on the bottom of our mole map. Now to our calculator. When we hit scientific notation, we use the scientific button here, sits on top of the comma, EE. And I'll just show my screen. Please punch with me so we get a common answer. Hit on your calculator, 1.5. Second function comma will show the E button on the screen, and that's to the 23rd power. Avogadro is on the bottom, which means we will divide by 6.02 E23. Our number of atoms, mg, divided by Avogadro's number. And the answer that my screen shows, 0.25 is the number. The unit is the label moles of Mg. 0.25 moles of magnesium. Our second problem. How many molecules are in 3.15 moles of molecular oxygen? Did you know that horses need oats for clear brown eyes? Oxygen in nature exists as a diatomic molecule. Again, this is a vocab match, just stressing that it's a one-step problem. We're being asked to count molecules, and we're given a molecule. This time we'll start by writing our number, 3.15. The unit is a mole, and the label is molecular oxygen, O2. If we're at the mole and want to head out, we're at the mole, heading out, we see that Avogadro gets placed on the top. These individual particles are now looking like molecules of oxygen. 1 mole of oxygen contains exactly 6.02 times 10 to the 23rd molecules of oxygen. MLC will be my abbreviation for molecules. Taking your calculator, hit with me please. 3.15 times, because Avogadro's on the top, we're going to multiply this time by 6.02 E23. Take a moment and hit that and see if we get a common answer. Moles times Avogadro, and we find 1.89 or 1.90, however you round would be fine, times 10 to the 24th. Remember to look all the way down to the end of the screen to get the times 10 to the power, 24th. And the label is a molecule of oxygen. Remember the great strategy: pause the video, hit it, and then check our calculators to make sure we get a common answer. Very important that you hit the keys with me. Don't save the calculator test until the test day, making calculator our buddy the whole time. All right, so our third question: how many atoms are in 7.12 moles of propane, C3H8? We are giving something larger. We're giving a compound, C3H8, and we want to count individual atoms. This to me is a vocab mismatch. This will look like 2 steps. As usual, first thing to do, write your number, 7.12. The unit comes directly after that. That's moles. And the label here for propane, this is a type of gas we probably have attached to our gas grill, C3H8, is called propane. This type of particle, if we're thinking about individual particles, atoms, molecules, or formula units are my choices of things we count in chemistry. We count atoms, molecules, or formula units. The correct label of the item we're counting is a molecule. C's and H's are both nonmetals hooked together, so we have to label that as molecules. There would be exactly 6.02 times 10 to the 23rd molecules C3H8 in every 1 mole of C3H8. We're not done because right now we're at individual molecules. We can count atoms making up that molecule. When I look inside the formula of C3H8, again, this type of compound is bigger than an atom, so I knew it would involve 2 steps. In every 1 molecule of the compound C3H8, I count 3 carbons plus 8 hydrogens. That's a total of 11 atoms of C and H. 11 atoms building a larger compound called propane. Hit with me on the calculator. 7.12 moles times our avogadro, 6.02 E23, times 11 for the number of atoms. Hit equal and see if we've gotten a common answer. My screen says 4.7 times 10 to the 25th power, and that becomes atoms of carbon and hydrogen. 4.7 times 10 to the 25th atoms of C's and H's. One more in our problem. How many moles of ammonium ions? Ammonium is the positive polyatomic NH4, and it carries a +1 charge. We're given a large number, 5.98 times 10 to the 24th formula units of a compound, ammonium sulfate. Ammonium sulfate are 2 polyatomic ions